So let's continue our discussion on this wave optics, and this is lecture number lecture 2. And if you remember, yesterday we had the discussion of interference, and I found some conditions on maxima and minima. Do you remember those conditions? So the condition on maxima was what? D sine theta should be equal to n lambda. Yes? And if you remember, this sine theta was approximated to y by capital D. Yes or no? And then we wrote the general form that yn was n lambda capital D by small d. That was the position of the nth bright fringe. Yes? What is the condition on minima? Who is this talking? Who is this idiot that doesn't understand I am teaching? D sine theta was odd multiple of lambda by 2, na? And then we found a condition, capital Yn was, I think, n plus half lambda d by small d. Yes, in both of these conditions, from where does the n start? No, for both of them it starts from 0. 0, 1, 2 and so on. Here also 0, 1, 2 and so on. Then if n equal to 0, then this can only be satisfied when theta equal to 0, na? Because d is a non-zero number. So theta equal to 0 corresponds to what? Come back to the diagram, and what does it see? There are two slits, na? S1 and S2, and there's a screen, and this is my center line. And the center line, you are making an angle with the center line, na? If theta equal to 0, that means you are here, right? Yes? Then that theta equal to 0 and n equal to 0 corresponds to a maxima, and that maxima is called 0th maxima. 0th maxima. And now let me make some more maximas, and then you tell me what corresponds to what. So what is this equal to? So n equal to 0 for 0th maxima, na? Here n equal to 0. What about if I am talking about 5th maxima? What will n correspond to then? 4. Should be n equal to 5. Because first maxima corresponds to n equal to 1, second maxima corresponds to n equal to 2, 0th maxima corresponds to n equal to 0. This is 5th maxima. इधर से 0, 0th, first, second, third, अच्छा वो है, वो 4th ही है, बट मैंने उसको लिखा है वैसा. 5th होएगा तो n equal to 5. ठीक है? Now let's come back to minima. Okay? Minima में बताओ, when n equal to 0, then what is it? When n equal to 0, then it corresponds to first minima. These both are first minima. What does it correspond to? N equal, is it visible, this gray color? Are you understanding? So there's a slide, I wanted to highlight this. So when n equal to 0, it's 0th maxima. When n equal to 0, it's first minima in the respective formulas. And now let me ask you this. If somebody asks you what is the n value for 23rd minima? 22. Should be 22, right? Because it's starting from 0. And if somebody asks you what is the 24th maxima, then any 24. Do you understand the difference? Thoda sa changes hai. So please be mindful of that. And these changes are only coming because I have put here 2n plus 1. If you remember, I wrote 2n plus 1 lambda by 2. In some books they use 2n minus 1 lambda by 2. That's also an odd multiple, but n starts from 1 in that. Huh? Do you understand what I am trying to say? This could be n minus half as well, lambda d by d, but then the condition will start from 1, and then everything will be normal. First minima n equal to 1, second minima n equal to 2. But since I have written this formula, that's why there is a little bit of this. You can follow either of them. Whatever you follow, then be mindful of what you are writing. Is it okay? I will stick to this n plus half wala. Since I have written it everywhere, so I will stick to it. So please write it in a note, this, all of this, and write it in a note ki 23rd maxima has n equal to 23, but 23rd minima has what? What does 23rd minima correspond to? n equal to 22. Yes, zara be mindful of this, okay? Yes. Is it okay with everyone else? Please copy so that I can go forward.
So mathematically the maxima starts from 1, 2, 3.
This is central and then it starts from 1, 2, 3, 4.
So if they ask first maxima,
then first ye hai. N equal to 1 is first maxima. If they are talking about the 0th maxima, then this is it. Or if they say the central maxima, something like this. Do you understand? So this is one thing that you should remember. And please write thoda jaldi jaldi. We have a lot to cover today. Okay, so let's come back to our topics, and the next topic is the relation between the fringe width and the wavelength. Or the I should give the appropriate name, dependence of fringe width on wavelength. Anybody remembers the formula of fringe width? This is the formula, right? Lambda capital D by small d. If I do an experiment, let's say, and I fix my small d and capital D, and now I am changing my sources, and by that I mean I am changing my wavelengths, then can you see that the beta will be dependent on the wavelength? Beta is directly proportional to lambda if my small d and capital D are fixed. Yes? So now this has very huge consequences actually. Ki, let's say in notes, some notes, and the first one will be, what if I do the experiment, this interference experiment in air, and I get some results, I get a beta, let's call it beta naught, okay, some for wavelength lambda naught. But now I do the same experiment where I immerse my apparatus in some liquid of refractive index mu. What will happen to my wavelength? What will happen to my wavelength if I immerse the whole thing in a liquid of refractive index mu? It will decrease by what factor? Yes, because lambda, if you remember the definition of mu, C by V, that means V is equal to C by mu. Light waves, the frequency doesn't change when you go from one medium to another. That means wavelength has to change, na? V equal to F lambda. So that means lambda becomes lambda naught by mu. We have already discussed all of it. So when the light rays are going through a medium of refractive index mu, the factor gets decreased. So what will happen to beta then? that will also get decreased. And do you understand what will happen then? Beta is what? What does the beta represent? Beta is the distance between two successive bright fringes or two successive dark fringes. That distance gets decreased. That means the whole pattern gets shrunk. Yes, that is what is happening if you put inside a liquid. So let me write it in YDSE experiment. That means what? The fringe width decreases by a factor of mu. Fringe width decreases by a factor of mu. And what is that beta naught? That is the fringe width as observed in air. Okay, I'm not writing that. Hopefully it is understood. So that's one consequence. And now understand this, I have been talking about YDSE in the sense, and I have been taking the sources to be of the same wavelength, है ना? And single wavelength, that is much more important. I have been taking single wavelength, but that's not necessarily true, na? Maybe you have some light which contains multiple wavelength. Can you give me an example where it contains multiple wavelength? Any light which contains multiple wavelength? White light. A simple example would be white light. It contains a spectrum of colors. If I were to use white light, then what will happen to the whole thing? So can you see that for each light color, there will be a pattern, and each light color will have its own fringe width? Yes or no? Then let's see. I'm going to take two examples. For white light, lambda of red is much more greater than lambda of violet, na? By the way, that means that beta of red is much more greater than beta of violet. तो यानी कि each color will produce an interference pattern, and the colors के जो bright fringes है or dark fringes, they are not necessarily of the same size, or they are not necessarily coinciding at the same point. It's not true that since the beta is different, it's not necessary कि यहाँ पर अगर first bright fringe of yellow है, then you will have the first bright fringe of green as well. Not necessary, because their betas are different. Betas meaning what? Distance is different. So it may be a little up. Little up. So then you have a very, very complicated phenomena here. If you have so many colors now, so for each color the whole thing will be, it's like a superposition of so many colors. Somebody roughly by closing their eyes, they have painted the whole thing with different colors. Will be something like this. But we will not complicate so much. Let's take an example where we are taking only two wavelengths. Okay? What will happen there? Is this point understood?
White light, 7 different colors are formed, right?
Yeah.
It consists of 7 different colors. Each have different betas. And at some point, at some random 23 or 24 point, they meet at a single point. All the 7 colors.
Not necessarily.
They might.
They might not. This is what I am talking in the third point. That will clarify everything. Let's say कि I am taking a light source which gives off bichromatic light. Do you understand meaning of bichromatic light? What was monochromatic light? So what is bichromatic light? Two wavelengths. And just for example, I am going to take violet and yellow. Okay? Violet and yellow. So लेट्स से कि आई मेक द पैटर्न, ये स्क्रीन के ऊपर पैटर्न दिखेगा, ठीक है. अच्छा, लेट मी ऑल्सो आस्क यू दिस वन थिंग कि इन दिस पॉइंट इटसेल्फ कि what will happen to all colors. So all colors will have different betas, na? That means their patterns are going to be little different. What will happen on the center? For all of them theta equal to 0 at the center, na? So all of them will meet at that point, yes or no? Maybe they will not meet at other points, but they will meet on this center, because everyone will make a central maxima, and with respect to which the beta is different for all of them. So at the center, at theta equal to 0 position, what is formed? A white 0th maxima is formed. Yes or no? A white 0th maxima is formed. Now let's talk about other points. I am going to take two colors, पर्पल एंड ये क्या बोलते हैं अपना येलो. लेट मी टेक कि ये चलो ये 0th है और ये एक ब्राइट है, ये ब्राइट है, ये भी ब्राइट है. These are the things that are forming. Okay. Let's talk about, and this is the beta of violet is going to be least, na? Yes or no? Because lambda of violet is least, so beta of violet is least. And this is my 0th maxima. What will happen for yellow? Yellow का 0th maxima will always be here as well. But now इसका beta is a little more than that beta. So इसका beta is little more, that means इसका first bright may be formed here. And then इसका second bright may be formed here. Are you understanding? इसका first bright is formed here and second bright is formed here. This is how the pattern will go, and then the third bright may be formed here. So now understand this. Some regions, see, ये जो black वाला part है ये क्या है? Dark fringe है वो. Dark fringe जहाँ पे मैं कुछ भी नहीं बना रहा हूँ. That's a dark fringe. तो in some regions, this was the dark fringe of violet, and then a yellow का bright fringe got inside it. So some places a dark will coincide with a bright of different colors. अब इधर देखो, what is happening here? A bright of violet gets coincided with the bright of yellow. What is happening here? A dark of violet is getting coincided with the dark of yellow. So what will form there? There will be a complete darkness. Complete darkness, because there is no intensity there. So what is this region called? Region of complete darkness. Do you understand the possibilities? I have taken only two colors for simplicity. What can happen? I am saying it once more. Always the 0th maxima will coincide. उसमें कोई problem ही नहीं है, because both of them will follow the condition theta equal to 0 corresponds to 0th maxima.
So after every color there is complete darkness, right?
Not necessarily.
Sir, because
हाँ, यानी कि हाँ, after every bright fringe there can be.
so because at one thing dark fringe of yellow and dark fringe are matching, and after that dark fringe of purple and dark fringe are coinciding, right?
Yes, ठीक है.
So like after every bright fringe there is
This is only an approximate diagram, just for your understanding. May not be the most accurate. Maybe this thickness is a little more. I have made only 2 lines, ऐसे कुछ तो.
but after every bright fringe there is a dark fringe.
I am not making that statement right now. I will check it and I will tell you later. But at least the possibilities that I can see here are that bright of one color may coincide with the bright of the other color, and there will be huge intensity there, and some color will be formed. It won't be the same color as what you used initially. Dark of one color may coincide with the bright of one color, yes, and the color of that will be seen there. And then dark of one color will get coincided with dark of another. That will be complete darkness region. Does it make sense to you? For both of them. this is only possible. Why? Because betas are not same. Because betas are proportional to lambda. Are you understanding the whole thing? Make the diagram, and then the formulation or the formula that they will follow for maximas would be d sine theta. So if let's say two bright spots are coinciding, that means they are subtending the same angle. It may not be true that the numbers are same. It could be like the second of yellow is coinciding with the fourth of violet. Could be that as well. You can't generally say because the thickness is not the same, na? Yes or no? So I am writing n1 and n2 in general. So d sine theta is equal to n1 lambda 1, and then since they are coinciding, the angle is same. Angle is same meaning d sine theta is n2 lambda 2. Then what would be the condition? n1 lambda 1 should be equal to n2 lambda 2 for them to coincide. Can you make a similar condition for minimas? Then you can also make a condition where a maxima and a minima are coinciding. Yes or no? Then d sine theta of one maxima should be equal to d sine theta of another minima. And then you can make so many conditions. Are you understanding whatever I am saying? Please write it. Getting it? All of you. समझ आ रहा है?
May not be that all three conditions will compulsorily happen.
I'm just taking all possibilities. I can't say anything in general right now. And please use color coding. ऐसा मत कि ब्लैक से कर दो उसके बाद फिर समझ ही ना आए. Try to use some colors. Crayons लाते हो ना तुम लोग? I thought crayons use करते हो. Again, I am only saying for bichromatic light. It would be even more difficult when we talk about tri or more colors.
What he said was correct. Lights will intersect at a point at the LCM of all the wavelengths. LCM?
क्या बोला?
The fringes will again intersect at another point other than the zero mass. So they will.
They can fringe. Obviously they can. That is what is happening. Na? The possibilities are there.
Like the bright fringe of one light and the bright fringe of the other light, they will intersect at multiple points other than the zero.
Yes, obviously that can happen. Obviously that can happen.
So for more than two,
We will do some question where we will actually find that there are multiple positions where maybe bright on bright are coinciding or dark on dark are coinciding. We will do questions like that.
for more than two wavelengths, isn't it n1 lambda 1 equal to n2 lambda 2 equal to n3 lambda 3?
Yes, should be like that. Should be like that. Is it okay? Can I go forward then? Let's do some questions on this thing then. So question number 1, please write with me so that you can give some time to solution actually. The time that I gave you for solution, don't write the question tab. Just to show that you are doing something. This is the question. I'm giving you 3 minutes to think, then I will start. Attempt. So at 12:25 I will start.
So this is 7.
Only 7? Incorrect.
So 7 by 4.
7 by 4. What does it mean?
Like minimum value for lambda 1 to overlap the lambda 2.
ऐसा नहीं.
N1 into 7.
N1 should be 7 and N2 should be 4.
What does it mean?
The seventh maximum of first wave.
Sir, N1 is 4. N1 is 4 and
7th bright fringe of something is overlapping on the 4th bright fringe of something. ऐसा पोलो ऐसा. तब आंसर आता है.
So lambda 2 is bright red, sir, over here.
Lambda 2 is what?
Bright fringe, so then
ऐसा कुछ नहीं है. दोनों का ब्राइट फ्रिंज ओवरलैप कर रहे हैं बेटे. ये दोनों कलर की वजह से बता रहा हूँ मैं. करेक्ट है.
Order of bright fringe of lambda 1 right?
नहीं बेटे. Overlaps with the bright fringe of lambda 2. You have to say the complete answer.
The question is only about lambda 1.
Hmm?
The question is only about lambda 1 right?
I am telling you to tell me both of them. ठीक है. Should I start? It's very simple, na?
seventh bright fringe means 4th dark fringe.
Not dark. दोनों bright. Let me see. So what would be the condition? The bright fringes are going to coincide, na? That means they are subtending the same angle theta. So any d sine theta should be equal to n1 lambda 1 and d sine theta should be equal to n2 lambda 2. And based on this, this is the condition of overlapping, na? Of overlapping of maximas. तो फिर बताओ क्या होएगा. n1 lambda 1 should be equal to n2 lambda 2. That means n1 by n2 should be equal to lambda 2 by lambda 1. And what is that? It will be 7 by 4. Now it need not be true that you can't generally say that n1 is equal to 7 and n2 equal to 4. Why? Because there are infinite possible solutions. It's a two unknown one equation kind of thing, and that will be infinite. So there will be other solutions like 14 by 8 or 21 by 15 and so on. They ask minimum. That is the main catch, that they are asking the minimum possible value that you have to reduce to the minimum possible fraction. So that means what? That the n equal to 7 and n2 equal to 4, and this means 7th bright fringe of lambda 1. So all of this means 7 coincides with 4th bright fringe of lambda 2. Does it make sense to you? 20? 21 by 12. Achha. Is it okay now? So let's do a slightly difficult question. I think this was extremely easy. Let's try this one. Now I'm giving the options. Attempt. Okay. I will start in 4 minutes. So at 12:33 I will start with the question. This is a good question. Attempt. It's 28 millimeter in the option D. Looks 18.
Sir, the wavelengths are nanometers.
Yes, that's in nanometer. nearly time. Should I start? Any answers?
1400.
It's millimeter. No. I'm waiting 2 more minutes and then I will start.
I got B, but I'm getting 10 part wrong.
Option what? D.
B, bomb.
Option B, Bombay. Doesn't matter, it's incorrect. Come on, it's not that hard. A is also incorrect, so everybody gave all the incorrect answers. Should I start? Option C is incorrect.
So if you want the remaining
It's given that you have 2 wavelengths and small d, capital D, all these things are given. Now they are asking to find the distance between 2 successive complete darkness. That means dark fringe on dark fringe. And what was the condition of dark fringe? So your angle subtended has to be same. So d sin theta should be equal to कितना होता था? 2n plus 1 lambda by 2 क्या? This is the path difference. And let's take d sin theta should be equal to 2m plus 1 lambda by 2. Lambda 2 by 2. I am taking n and m here. These are the conditions of complete darkness. Your dark is on the dark because the angle theta subtended is same. So from this what will you get? You will get 2n plus 1 lambda 1 by 2 should be equal to 2m plus 1 lambda 2 by 2, and then you can say 2n plus 1 by 2m plus 1 is equal to lambda 2 by lambda 1. What is lambda 2? 560 divided by 400. And what is the reduced form of this fraction?
5 by 7, 4.
7 by 5. 7 by 5 is the reduced form. And it need not be that solution. I can't directly say 2n plus 1 equal to 7. There are infinite solutions, yes? But all of those solutions correspond to complete darkness. That is what I am saying right now. And they are saying to find the distance between 2 complete darkness. So at least I have to find the first minimum possible point and just the next second point. So I have to take into consideration all the possible values. Take 7 by 5 है और इसका distance minimum distance between 2 successive complete darkness. ये complete darkness को correspond करेगा. अब एक और point चाहिए ना जिसमें से distance निकालूंगा. तो एक और point के लिए मैं और possible values ले सकता हूँ. What are the next possible value? 14 by 10. Anything next?
28 by 15.
21 by 15. And you can go on so on. 28. 21 by 15 is correct ना? 7 का टेबल पढ़ो बेटा. कोई बात नहीं होता है. तो this is what I am having. So I will try to find the n and m value for the first complete darkness, and some of those values need not be physical real values. They may come in decimals. If n equal to 5.5, then is it a valid value? Our n has only whole number. It can only be a whole number. So if that is a decimal value, we will discard it. That's why I have written so many solutions. The first, let's start with the first value. This is trial and error. Take 2n plus 1 divided by 2m plus 1 should be equal to 7 by 5.
Are we going to get the answer even if you take lambda 1 as 400 and lambda 2 as 560?
This is what I have taken.
Reciprocal. What if we take lambda 1 as 4?
Doesn't matter. Doesn't matter. तो ये अच्छा, what will this give? 2n plus 1 is equal to 7. Then what is the n value? 3. And what about 2m plus 1 is equal to 5? What is the m value? 2. Then can you see, are these whole numbers? So they are perfectly viable solutions. So now you can say that the third dark fringe is coinciding with क्या होगा ये? n equal to 0 corresponds to first dark fringe. तो n equal to 3 fourth dark fringe of what wavelength? ये किसका wavelength का था? n1 lambda 1. So this is third dark fringe of lambda 1 is coinciding with what? बताओ ये क्या है? ये नहीं, थर्ड नहीं है ना, ये फोर्थ है. ये फोर्थ है. The fourth of this is coinciding with third of. नहीं बेटा, सेकंड नहीं होगा. अब सोचो क्यों नहीं होगा. बहुत बार डिस्कस किया. अरे बेटा सब डार्क ही है, तभी तो कंप्लीट डार्कनेस मिलेगा. अगर एक ब्राइट और एक डार्क आ गया तो कंप्लीट डार्कनेस मिलेगा क्या? नहीं आएगा. This is the first solution that we have. Let's check the second wala. If we are lucky, we will get it in the second fraction itself. Let's check it. Take 2n plus 1 divided by 2m plus 1 to be equal to 14 by 10. Now what is the n value from this? 6.5. And what about the m value? Are these acceptable solutions? No, so we will discard it. We'll go to the next solution now. And what is the next solution? Why not the? Why are we not discarding this? These are whole numbers.
So we want whole numbers.
अरे whole ना, हाँ तो ये क्या है ये?
The first option.
What do you mean by first option?
n equal to 3 and n equal to 2. Why did we take?
These, अरे ये idiot, इसका मतलब है कि on this pattern my third of this is coinciding with the second of this and I am getting one complete darkness. I got one complete darkness. I want another complete darkness so that I can find the distance between them. Now take 2n plus 1 divided by 2m plus 1 is equal to 21 by 15. बताओ n equal to क्या है? 10. m equal to 7. Then are these acceptable solutions? So we found our solution. I am not going further because they have asked for the minimum ना. इसके बाद यही है ना next acceptable solution, तो ये minimum हो गया distance. अब बताओ how to find the distance then? We have a y का formula ना from the thing. Yes? So now understand this. It does not matter which wavelength you are going to use because the points are coinciding ना. So let's take for wavelength for lambda 1. If I do the calculations for lambda 1, so this is what? Fourth. So this will be y what? y4 लिखूं या y3 लिखूं? y3. And there will be a y10. These are the points of complete darkness, huh? Yes or no? Then now I can find the distance between them, or yes or no? So do you understand why I was finding this n equal values? See, there is no nothing new here. You can do the same thing for the other wavelength and then consider what will be y then here.
2 and 7.
That will be 7 and 2. y7 minus y2 करना पड़ेगा फिर. But then take the other wavelength. Are you understanding why I am doing like this? Pakka? Then let's try to do it. And what was the yn ka formula? Can somebody remind me? n plus half lambda capital D by small d. ऐसा formulas याद रखो. Then what is the distance? y10 minus y3. That's 10 plus half lambda d by d minus 3 plus half lambda d by d. And I think ये तो गया. 10 minus 3 7 lambda d by d. Is it okay? Now substitute the values and get the answer. What is lambda? 400 power minus 9 nanometer. d कितना था 1. Small d कितना है? Is it okay? अब इसका आंसर चेक कर लो कितना आ रहा है. पावर 9 पावर माइनस 9 पावर माइनस 7 हो गया. नीचे से प्लस -3 ऊपर गया +4 हो गया. -4 है ऊपर गया +4 हो गया. -7 +4 -3 10 पावर -3 बचा. That's y10 minus y3 and this is my answer. Do you get the question? If you do it yourself logically you will get it बहुत simply. ठीक है? Got the answer? Did you use the other wavelength? 560 वाला. बहुत same answer है, correct है. Do you understand how to choose the solution and why am I discarding the other one? So please copy and once you are done then tell me. इतना तो लिखा ही होएगा ना hopefully. जाओ जाओ सब साथ में जाओ जाओ मुझे कुछ प्रॉब्लम नहीं है. अभी टाइम दिया है लिखने के लिए तब तक जाके वापस भी आ जाओ. बोलो.
I found out where the dark bright fringes are formed.
Bright.
Yeah, bright. So it has an interval of 7 every bright fringe.
It has what?
Interval of 7, like every 7th, after every 7 fringes there is a bright fringe.
After every 7th fringe there is a total brightness. There is a total brightness.
So
ठीक है.
8th fringe there is total brightness, and at the 15th fringe there is again total brightness.
ठीक है.
So there is an interval of 7.
Okay.
That interval will be same for complete darkness also. So 7 will be the difference.
You can say it like that as well.
Then we can put it in the formula.
But then this should click in the exam. That's also correct. But that interval that you're taking, that depends on the lambda, okay?
Yeah,
Because
we took
now
the
you are
lambda.
only multiplying, huh?
We took this relation also. So we get 7 by 5 like that.
Achha, now you are taking only 7 to फिर lambda 1. If I take the other one then correct ही है. That's also correct. बोलो.
I took this opposite wavelength, sir. 7 by 4, I got 4 by 7. And if we solve
Now your n or m value will get interchanged.
yes, it doesn't matter, but always the multiple of this is always an even number. And if I subtract an even one from even number, I'll get odd. It always help me getting a fractional digit.
तो नहीं ये ऊपर का न्यूमरेटर ओनली कंपेयर विद ऊपर का न्यूमरेटर.
2n plus 1 equal to some 16, 20, 24,
Yes.
everything is even. And if I subtract 1 from an even number, it's always odd. So if I divide it by
You are getting 4 ना. It's 5. सही से डिवाइड करो. So is it done? So I'm going forward with the topic. Let's check ki if you have a slab, a glass slab, let's come back with it, and you put it in front of one of the slits, then what happens to the pattern? Let's see that. हाँ वो बताऊंगा अभी मैं. Where's my book? There. Is it written for everyone? Everyone has written it? So we have talked about dependence. Now let's talk about path difference due to a glass slab. Path difference due to a glass slab. Okay, let's consider two rays. I have a glass slab of refractive index mu, and let's say everywhere else the refractive index is 1, that's air, and I have some source from which this ray 1 is coming, and there's a ray 2 which is going here. Okay? And let's say this is the point that they will end at. This distance, this is ray 1 again, this distance I am calling y, and this distance covered is x. And what is the total distance here? X plus y. Then what is the time taken by this second ray to travel this x plus y distance? What is the time taken by the second ray to travel x plus y distance?
X plus y by v.
X plus y by, that's a light ray. X plus y by c, that's c. So speed equal to distance over time, time equal to distance over speed, t2 equal to x plus y by c. Yes or no? And then what will be the case here? Here can you see that the velocity in this region when you enter the glass slab will be different. It will be x by v plus y by c. And what is the relation between v, mu and c? Mu equal to c by v, so v equal to c by mu. Yes or no? So what do you get? Mu x plus y divided by c. So when you go through this glass slab, the light ray actually takes longer time to travel to come here, and you can even assume it to be that you are traveling more distance. You're traveling more distance, mu x plus y, that's why it looks as if you are taking longer time. Yes or no? So if you are traveling more distance, let's say there are two waves which are starting at same point, but this one has traveled a little more. Will there be a path difference between these two waves?
Yes.
There will be a path difference, huh? And what is the path difference equal to? Extra path covered. This path difference is equal to extra path covered. Are you understanding whatever I am saying? The first ray will travel extra distance, and due to that there will be a path difference. Now what is that path difference equal to? That will be this distance, mu x plus y minus x plus y. And what is this equal to? Mu minus 1 into x. And I think it should be very clear that x is the thickness of the slab. Yes or no? I did not write t because I used t2 t1 times ke liye. So that's why I wrote x. Is it okay with you? Then you can understand that as soon as you put a slab in front of one of the rays, it suffers a path difference of mu minus 1 into the thickness of the slab. Does it make sense to you?
But the distance covered is same, right?
No, it's not.
Like how is it different?
You're traveling more distance in this. You're traveling mu times x. That's why it looks as if it is slowed down. Bolo.
Space that is occupied by that glass slab is same, right?
No.
If I add a glass slab,
This is the same thing that we come back to. I told you earlier when I was talking about what is the meaning of mu. What does this refractive index does? And you remember I talked about this phase kickback, and I also said ki velocity of light never changes. It's the same everywhere, and as you can see the velocity of light is same everywhere. It's just you are being kicked back again and again. Now you have to travel more distance in the same thing. Huh?
Sir, but the light is traveling that inside the glass slab with the velocity v, right?
Yes, velocity v.
Velocity is same.
But no. What is the final formula that you get?
But the assumption we made was that, right?
Are nahi, but that leads to this now. And now you can actually say that the speed of light never changes. It's just you are traveling more distance. And that's why it looks as if it has slowed down. It has never slowed down. You're traveling more distance in this glass slab.
Sir, you must be always traveling one direction.
Not necessarily. ये भी मैं डिस्कस कर चुका हूँ. अब ये तुम लोग मुझे 4 साल पुराने के डाउट्स वापस पूछते हो, फिर उसके बाद बोलते हो वापस एक्सप्लेन करो.
Sir, if it is less than 1,
It's okay. I'll discuss later. Not today.
so it will be faster, right, sir? Then?
Anybody remembers I have discussed this exact same thing in this class? Good. इसलिए रिवाइज करते हैं बेटा जो सर बोलते हैं. जब मेरे लेक्चर जाके देखो पता चलेगा म्यू वाले का. थोड़े व्यूज आ जाएंगे.
Can you explain the kickback in terms of phase?
In terms of
Phase.
it's just a phase kickback. Your wave get phase kickback उसमें या तो +5 कर दो या -5 कर दो. And the phase velocity changes. है ना? अरे +5 करोगे तो your wave gets shifted आगे. -5 करोगे पीछे शिफ्ट हो जाएगा. Is it okay? Yes, भरत. बहुत इंटेंस लुक है बच्चे का. कुछ तो बहुत ग्राउंड ब्रेकिंग लिख दिया मैंने बोर्ड के ऊपर. Is it understood by everyone? बताओ कितने लोग को नहीं समझा? हाँ. तो what to do now? YouTube खोलो, लेक्चर देखो, उसके बाद मेरा डिस्कशन ढूंढो, मेरा म्यू वाला डिस्कशन ढूंढो, उसमें मैंने सब बताया. क्या बोले? अब वो जाके खुद ढूंढो बेटा. कभी अगर बुक खोल के पढ़ लो ना तो पता चलेगा क्या पढ़ा था कौन से लेक्चर में. लेकिन बुक ही खोल के नहीं देखते बच्चे. Can I go forward? So it's apparent now that if you put a glass slab in front of a ray, it suffers a path difference of mu minus 1 into x, where what is x? I should write this as well. This is the thickness of glass slab. Yes? And what is mu? That's the refractive index of the slab. And we have done this derivation assuming that the surrounding medium has a mu of 1. What if it is mu 1? Mu equal to 1 liya idhar, but now I am saying surrounding medium has a mu 1 and the glass slab has a mu 2. What will you find then? I am not going to derive it, I am just writing the result, but does it look like this is mu by 1? So mu also it has to have the same dimensions here and there same. तो एक कोई रेशो ही होना चाहिए ना. तो यानी mu2 by mu1 हो जाना चाहिए. तो वही लिख रहा हूँ अभी मैं. ठीक है? So notes. If I have the situation where I have a glass slab, thickness T बोल देता हूँ अभी. ठीक है? and this is my ray. This is my ray coming out. 1, 1. This is ray 2. And the refractive index here is mu1, here is mu1, here is mu2. Then the delta x introduce or the produce is mu2 by mu1 minus 1 into x or into t. Is it okay with everyone? ठीक है. Make it what? ठीक है. You can do anything. कोई सिंपल गामा भी लिख लो, कोई प्रॉब्लम नहीं है मुझे, बट ये थिकनेस ऑफ ग्लास स्लैब है, बस वो याद रहना चाहिए तुम लोग को. That's why I keep on writing everything everywhere so that it's clear to you. Second point, that if you have a glass slab like this, and let's say, what does the lower surface acts as? That acts like a mirror. So you have a glass slab of thickness t and refractive index mu, and let's say there is a normal incident wave, not wave, rather ray ले लो. ये ray ऐसा आया, normally incident किया, ऐसे ही जाएगा ना, without any deviation. It goes like this, and what will be the reflected ray? Just exactly like before ना, ऐसे ही चला जाएगा, ऐसे ऐसे. But just for simplicity I am going to make that reflected ray here so that it is visually okay. ठीक है, but understand कि वो coincide कर रहा है इसी ray से. ठीक है. So this is this. This is my reflected ray, reflected from lower surface. Acha, when this ray actually comes and when it hits this surface, the upper surface, then do you remember when a ray goes from one medium to another medium, there's always a possibility of partial refraction and partial reflection? Yes or no? So there is a possibility that maybe there is a ray which is reflected from here itself, यहीं से. And please remember, ये तीनों rays एक ही line में है. वो तो मैं I have made them other. तो अब मैं points के नाम दे देता हूँ, A, B, C, D, E, and A, E, C coincide. ठीक है ना? Remember this. Then the refractive, then the path difference between this ray, which is reflected from the lower surface, and this ray, which is reflected from the upper surface, the path difference is 2 mu t. I am not deriving that as well, I am just giving the result. Path difference between rays reflected from lower surface and upper surface is equal to 2 mu t. ये याद रखना. Is it okay with you? Is it okay? So please write a little fast, we are being behind. I want to talk about some more things. चलो जल्दी जल्दी हाथ चलाओ एकदम. नोट्स कंप्लीट हो गए?
3 पेज.
अभी भी 3 पेज बचा हुआ है. Is it done? Can I go forward? So let's talk about, why did I talk about this glass slab? Because I'm going to insert it in our apparatus. You remember our apparatus for the YDSE? There were two slits and there was a screen, and you remember there was a naturally found path difference. Let me make the diagram and then let me talk. तो टॉपिक का नाम क्या दूँ? Shifting of fringes. Due to glass slab. You remember this apparatus or the setup was something like this. You have two slits, you have a screen, and this is S1, S2. And we were talking about whether when they meet at some point P, then what is the thing that you will find at this point P? How can you directly say? कुछ भी बोलता है. This is capital D, this is small d, and this is the distance y from this. Yes or no? This was our setup. And you remember that I made a diagram like this where I assumed these to be lines, and then I told you I will drop a perpendicular, and I said ki this line and this distance S2C was considered to be our path difference. And what was the path difference that we found it to be? That was d sine theta, if you remember. This is the path difference that we found. Now I am going to slightly change my setup where I will take, I am erasing all of this now, and I am putting a glass slab now in front of the slit, because why not? Let's do just for fun. And what will you get then? So it has a thickness T and refractive index mu. If I write like this, are you okay with it? Glass slab of thickness T and refractive index mu. And now my waves will go through here and they will go through here. The rays which are, I keep on saying rays, it's waves. The waves which are going from S1 to P, they will suffer a path difference. Due to what? Due to the glass slab. And then S2P naturally has a path difference which we have already found out, d sine theta. Na? So there are two path differences here, and if I want to find the final path difference between these rays, then what should it be? Should I add the two path differences or should I subtract? He says add. Anybody else? Subtract. Why?
Sir, initially it has d sine theta. That means S2 is given by d sine theta. And that is going to the glass slab, so it will cover more distance.
Yes. Yes. So it's something like this. Maybe the S1P I am going to talk with very bekar sa example, but hopefully it delivers. That let's say that after slab you cover 4 kilometer when you go from S1 to P, and when you go from here to there, naturally you cover 5 kilometer. Then what is the distance between the two waves? Is it the addition of the two or the subtraction of the two? Subtraction. So what should I find the path difference to be? The delta x. First let me find the path difference due to 1. That's what? Mu minus 1 into t, na? We have already found out. And what about delta x2? That's d sine theta. And if you remember that the d sine theta, the sine theta can be approximated to tan theta, and tan theta from this big triangle is y by d. So that's small dy by d. And what will be the final path difference? This will be delta x2 minus delta x1. That will be y small d by capital D minus mu minus 1 into t. This is my new path difference after I insert a glass slab there. But now you should understand the maxima condition and minima condition will be changed. Why is that so? Because you don't have the same part difference now, na? What was the condition of maxima? What is the part difference equal to for maxima? Huh? What was the condition of maxima? Come on, say. It's n lambda. Delta x equal to n lambda. That's the condition of finding a constructive interference. Huh? So delta x has changed now. It's not yd by d now. It's yd by d minus this something. So I have to write the new condition. So the new condition of maxima will be what? It's already delta x should be equal to n lambda, where n starts from 0, 1, 2 and all those. Then what is here? So n lambda should be equal to y, and let me write y subscript n d by capital D minus mu minus 1 small t. Then what is small yn? That's d by small d n lambda plus mu minus 1 into t. And this is the position of the new position of the nth bright fringe. This is my new position of nth bright fringe after inserting a glass slab. Now tell me this. The first bright fringe was located here, but now it gets shifted by some amount. Now you are adding some amount, so it gets shifted up. Yes or no? Will that happen with the second maxima as well? It will, because it's a constant shift, na? Doesn't depend on n. So all the maximas are getting shifted by this much amount of constant amount. That means the whole pattern is getting shifted amount by the same amount. So what happens when you put a glass slab? The whole fringe or the pattern gets shifted. And by how much shift? That means the pattern gets shifted by mu minus 1 into t small d by capital D. This is the shift key value. It's a constant shift, doesn't depend on n or lambda. And if you think like maybe the shift in dark fringe is not the same, then you can write the condition yourself and check that the shift will come out to be exactly same. Okay? And that means the dark fringes are getting shifted by the same amount. The bright fringes are getting shifted by the same amount. They are shifted in the same direction. So the whole pattern gets shifted. Yes? So that's the only thing that a glass slab does. Okay? It's getting shifted by this amount. Can you tell me what happens to beta? What was beta?
Lambda d by d by h.
What was the meaning of beta?
The distance between two successive
Distance between two successive bright fringe. Is that the same still, or is that changed?
Same.
It will be a same, na? Because the first bright fringe and the second bright fringe are getting shifted by same amount. Yes or no? So the distance between them is going to be same. So you can even check it yourself if you want. You can find the beta. That beta is unchanged. Is it okay with you? I just want to write 2 more points and then the lecture will conclude. So are you done with this till here? अच्छा कुछ देखना है? शुरुआत से लिखना है? वाह बेटा वाह, छापो जल्दी जल्दी. सो कोई प्रॉब्लम नहीं. ले रहा हूँ. Thank you. Is it done? I'm just writing 2 more points, and if there is time I will write one question. The first thing that we can find from here is that the shift that we are finding, what is the shift value? That's equal to mu minus 1 into t capital D by small d, na? You multiply this capital D by D in this, है ना? ये इतना initial था and then ये इतना हुआ. Yes? So that is the shift.
So then there should be capital D by small.
अच्छा, capital D by small d लिखा है. ये इधर problem थोड़ा capital D by small d, हाँ? Please correct it. Okay? So the shift is equal to mu minus 1 t capital D by small d. Does it depend on the n value or lambda? कहीं से dependence दिख रहा है? No. So independent of n and lambda. Is it okay? I'm just writing one more point. I will try to justify it in the next lecture. Not today. Just take it right now. That number of fringes shifted should be equal to shift divided by fringe width. Jao. And what is shift? That's mu minus 1 into t capital D by small d. And what is the fringe width equal to? Lambda capital D by small d. And I think this cancels. And at the end you are getting mu minus 1 t divided by lambda. That means the number of fringes shifted is inversely proportional to lambda. Number I will try to justify the second point next time, huh? Not today. If you are done with this, then tell me. I will just write one question. You can take it as a homework or you can do it right now. Anyways, I will do it in the next lecture. Did I give some homework question last time? Did you try it? What is the answer you are getting? 3? That's incorrect. 3 I naught by 4 and I naught by 2 is correct. So 3 by 4 I naught and 1 by 2 I naught. This is the correct answer. Attempt again. If you don't get it, then ask. Let me write the question. I should also tell you this. We found the shifting when I put my slab in front of S1. So please be mindful that I have only put the slab in front of S1, the upper slit. What if you do it for the lower slip? What if you change and then put 2 slabs? What if you put 3 slabs? What will happen then? So you have to work around these possibilities and play with it. Okay? It's much more better if you play with it and try to get your answer at home than to get surprised in the exam. There may be questions where I will put 2 slabs of different refractive indices, and then you have to work around it. So it's much more better if you do it, and if you get some answers, then tell me. Okay? So I'm not teaching anything more than this for today. You can take it as a homework and attempt it. So you can switch off the video.